Bismillahirrahmanirrahim. Today our lecture is about ethylbenzene production process by using Aspen Plus. Okay, today we do our simulation according to our problem statement. Here we have problem statement in which process should produce minimum of 15 kilomole per hour of ethylbenzene and using SRK method. The reactor which is used in the process is plug flow reactor, and the condition of reactor are 20 bar and 400 degrees Celsius, and the length of the reactor is 8 meter and dia of reactor is 1.6 meter. Residence time is enough and pressure drop of 2 bar. Okay, the component which we put in Aspen Plus component setup: ethylbenzene, ethylene, benzene, diethylbenzene, propylene, and toluene. Okay, so streams which we initially put in a mixture for our process: E stream at 25 degrees C and having pressure 20 bar is mixed with B stream with 5% toluene, and same conditions as E stream are mixed before sending to the PFR reactor. So product from the reactor is flashed at 142 degrees C. Vapor is recycled back to the reactor. Before sending to the reactor, propylene is separated from the stream and heated up to 190 degrees C and compressed to a 20 bar. Liquid from flash is sent to the distillation column, DSTWU distillation column, where benzene is taken as the distillate, which is recycled back to the reactor. Bottom product is then sent to the second distillation column, which is separate, and E stream minimum purity 98% and diethylbenzene minimum purity is 97. Okay, reaction in vapor phase. These are our reactions. Okay, the distillation column which we used in our process, having conditions: pressure 20 bar, reflux ratio between 1 to 10, light component ethylbenzene, recovery is 0.99, heavy component same for second distillation column. Now we move toward Aspen, so it will take some time. Then click on new and click on chemical process chemical with metric units. Create. It will take some time. So now first we add components: benzene, and second is toluene, third is ethylene, and 4 is propylene. Okay, this we find from our tab. Propylene, must edit, and next is ethylbenzene, and next component is diethylbenzene. Click on diethylbenzene and add. Next we choose method for our components. Here first we rename them benzene showing by B, toluene by T, ethylene by E, propylene by P, ethylbenzene EP. and diethylbenzene DEP. Okay, now choose method for these components. Here we are using SR method, so click on next. So required input is complete because parameters are not complete, so we go back on method and using stream NBS because we are using P or F. So click on next. So required properties input complete. Now we move toward simulation environment for further process. So first we add mixture, resize it, rename it mixture, having 2 inlet streams. That's our mixture, and we use our plug flow reactor for our process. Our plug flow reactor, give him name PFR reactor. Okay, so that's our product string. Okay, first add the composition of streams according to our given data. The E stream having 50 degrees C bar is mixed with B stream. So E stream having 25 degrees C and 20 bar pressure. Here flow rate in our mole and 50 kilomole per hour. That's our E stream, ethylene stream, and the component is one in which. Go back to main flow sheet and click on B stream and adding the specifications of B stream. Here temperature of B stream is 25 degrees C, 20 bar pressure, air total flow rate in mole and 50 kilomole per hour. So 0.95 benzene in this stream and toluene is 0.05. So click on reset and click on next. So then connect this with reactor. That's our product. Click on next, adding the specifications of reactor, type of reactor. Our reactor is specified with temperature. Okay, and 400 degrees C. As we mentioned in our the PFR reactor is operating at 20 bar and 400 degrees C. So click on configurations. Here the length of reactor is 8 meter and dia is 1.6 meter as we mentioned in our PDF. Okay, so after reactor dimensions, click on next. There are no reactions, so first we add reactions. Click on new R1 reactor power law. Reaction type is not given, so use power law mode, common type of reaction. So click on new. So adding components, here we have B component and ethylene component in our first reaction, coefficient 1, exponent 1 and 1. In our first reaction products we have EB and E. And that's our EB product, our ethylbenzene, exponent 0. Click on next. It's our first reaction, and adding now second reaction. In our second reaction, here we have our reactants, ethylbenzene, ethylene, and product we have diethylbenzene. Adding coefficients, okay, now adding third reaction. In our third reactant we have toluene, ethylene, and components we have 2, 1, 1. In our product setup we have EB propylene and coefficient 1, 1. Here exponents are 0. Okay, reactions are off. Now adding the kinetics of this reaction. First reaction, which is in vapor phase, and value of K in first 1 E plus 0.6, and the value of E is 22500 as we mentioned in our PDF. Okay, and molarity units are very important, so adding now for next reaction. So the value for next reaction which is in vapor phase, and value of constant K 6 power and power of E is 225 unit mole. And now for adding for third reaction, which is in a vapor phase, and value of K is 3.8 E plus 8 and N0, and E here we have 20,000. Units are very important. Okay, here we show blue text. It means our reactions are added. Click on next. It will take some time. So click on pressure. Pressure of our reactor is 20 bar. 20 pressure is 20 bar and stream pressure is 2 bar. So reset and click on run. Okay, so results are available. No error occur in our simulation. Here we see results of our reactor. Okay, these are results of our reactor. Now we move toward as we mentioned in our PDF. So product is flashed from the reactor at 102 degrees Celsius vapors, which is recycled to the reactor. So we are adding here flash. Resize it and connect the stream with flash. Click on flash. Here temperature 142 degrees C and pressure 0 bar. As we mentioned, 100 degrees and pressure is 0 bar. So no pressure. So click on reset and click on run. So results are available. Our bottom stream is liquid and our upper stream is vapor. So that's our flash. So as we mentioned in our PDF, product from the reactor is flashed at 25 degrees C, which is and vapor is recycled back to the reactor. So now we do work, vapors recycle to the reactor. According to our condition, here we are using separator for recycling vapors in the reactor. That's our separator. Must resize it and connect this vapor to the separator. So rotate icon, flip horizontal and adding 2 streams. So for upper stream is our that's our propylene stream. and that's our main stream. So click on separator. Okay, now here we are having this is 0 0 0 1 propylene, and ethylbenzene is 0, diethylbenzene is 0. Click on run. So the following until operation blocks were completed with a warning because 0 feet to the block bypassed. So go on main flow sheet because that's problem because of a prop. So as we mentioned before, sending to the reactor, propylene is separated from the stream, heated up to 900 degrees Celsius. Here we put heat exchanger to heat, providing more heat. Okay, so rename it HTR and connect propylene, connect stream remain to the heater. Okay, select heater and stream from heater. Rename it compressor, connecting stream 13 with compressor outlet. It's our remain 3. Remain 3 is hold on it. Because of some alignment issues. Okay, so click on heater which is operating at 192 degrees C and pressure is 0 bar. Okay, now go on main flow sheet, click on compressor. Compressor is isentropic type. Discharge pressure of compressor is 20 degree bar, and efficiency is isentropic 0.08. So must reset and click on run. So results are some warning because still is nothing in vapor phase. So leave it and we will continue our next further. So there are warning because still is nothing in vapor phase. So here we're using distillation, DSTW, as we mentioned. Compressor liquid from the flash is sent to the distillation column as we mentioned in our PFD. So give him BC1 and liquid stream is connect with distillation column. So giving them streams, that's our benzene and that's our bottom product. So we'll click on distillation column 1. So here we have in specification section 20 bar pressure, reboiler pressure is same, and reflux ratio is 10 as we mentioned, reflux ratio from 1 to 10. So in a light component we have benzene and recovery of benzene is 0.99. In a heavy component we have ethylbenzene at bottom and recovery of ethylbenzene is 0. Hold on 1 minute. 0.001. Okay. Now recycle benzene toward mixture. So click on reset, connect, recycle this stream back to the mixture as we mentioned. Now click on run. It will take some time. We are seeing errors because of the flow rate of benzene and ethylene. So where is our main flow sheet? And now changing the flow rate of is 7 kilomole per hour and flow rate of ethylene 80 kilomole per hour. By seeing the literature review or by trying hit our trial method to resolve this issue. So click on reset, click on run. Now for second distillation column, which is our last distillation column of our process. Here we put the data according to given data of DC2.
Minimum purity is 98% and ethylbenzene is 97% purity. So results are available of second distillation column. So here we see complete results of our process which we did. We done our simulation according to our problem statement. Here you can check results of each components as individual. Okay, kindly subscribe my YouTube channel and press bell icon.